Yeah, this test is from 419 Math 2, 419 Math 2 SNC test 1. And I would like you to try this, try work on this. And then, yes, in 2 minutes, we will start working on these 3 problems here. Basically on this page. Or do you need more time? Nobody say anything. Just in case you just come by, let me make it 9:45. So at 9:45, we'll start going over this first page here. I will keep the recording on. So that while you work on this, you're also aware with how much time you're supposed to spend on each question. Again, the number of points for that question represent the number of minutes you should spend for that question at most. Like number 2, 4 points means you should spend at most 4 minutes for that question. Okay, let's start. Let's start. We did this very similar question before, right? So I expect you to be able to do this already at this point. But this time we do it together, right? Now in your test, which is 2 weeks from now, approximately 2 weeks from now, you will do it on your own. The slope of the line will be y2 minus y1 over x2 minus x1. That's 10 over negative 8 reduced to be negative 5 over 4. And then the equation of the line, y equals to mx plus b. And let me use one coordinate 3 comma negative 2. That's negative 2 here. This is 3. So I get negative 2 equals to negative 15 over 4 plus b. Do the LCD, plus 15 over 4 equals b. So b is 7 over 4. So the equation of the line, y equals to negative 5 over 4x plus 7 over 4. That's part A. Part B. Find equation of a circle whose diameter is a segment with those endpoints. So I need to first find the midpoint. The midpoint is x1 plus x2 over 2 and then y1 plus y2 over 2, that is negative 2 over 2, and then 6 over 2, that is negative 1 comma 3. Right, let's visualize that. So these are the endpoints. That's 3, negative 2. This is negative 5 comma 8. We get the midpoint, which is the center. Now then, to find the radius, I will find the distance from one of the endpoint to the center, or the center to the other endpoint. Either one will give us the radius, right? Okay, so the second step, the radius squared equals to, let me use 3 comma negative 2 again. Okay, so 3 minus negative 1 squared plus negative 2 minus 3 squared. That's 4 squared plus negative 5 squared. 16 plus 25, that's 41. So the equation of the line is x plus 1 squared, y minus 3 squared equals to 41. By the way, the radius is square root of 41, right? So that's the equation of the circle. Part C, find the y-intercept of that circle. The y-intercept means x equals to 0, right? So 1 squared plus y minus 3 squared equals to 41. Y minus 3 squared equals to 40. So y minus 3 is plus minus square root of 40, which is plus minus 2 radical 10. So y will be 3 plus minus 2 radical 10. But we don't stop here. We don't stop here. Notice that the question is the find the y-intercept, right? Okay, find the y-intercept. So The y-intercept has to be in coordinate form. 0, 3 plus 2 radical 10. 0, 3 minus 2 radical 10. Okay. Part number 2. Find the equation of the line perpendicular to this line and passing through 5, negative 2. Let me use Precalculus way. So if I call this line 1, then line 2, which is perpendicular to line 1, means line 2 has this equation, 7x minus 5y equals to constant. Okay. You swap the coefficient of x becomes coefficient of y becomes coefficient of x, and then you change one of the sign. Then you plug in coordinate, let's say in this case, because line 2 passing through 5, negative 2, then I plug that coordinate in to find the constant c. That's 35 plus 10 equals to c, so c is 45. Therefore, the equation of line 2, which is perpendicular to line 1, is 7x minus 5y equals to 45. Okay, so this question is something we can do actually in, let's say, 2 minutes. Okay. However, if you go back to algebra method, will that be okay, Thomas, if I use algebra method? Because I understand it better. Of course, you're supposed to understand it. Okay, you're supposed to have understand that from algebra, right? What I'm trying to teach you is how to do it faster with Precalculus mindset. But if you insist on using algebra method, okay, so line 1, you need to find the slope first, right? So 7y equals to negative 5x minus 12, and then divided by 7. So the slope for line 1 is negative 5 over 7. Therefore, the slope for line 2 is 7 over 5. Right? Okay. Now then, let's say this is the first step. Then let me start here, second step. So line 2 must be y equals to 7 over 5x plus constant b, right? The coordinate 5, negative 2, y equals to 7. I'm sorry, the y is replaced by negative 2 now. The y is negative 2 equals to 7/5 times 5 plus b. That's negative 2 equals to 7 plus b. So b is negative 9. Therefore, the equation of the line is, equation of line 2 is given by y equals to 7/5 x minus 9. But Thomas, why this looks different from the answer you got earlier? They look different because they are in different form. Okay, this is in standard form, this one is in slope intercept form. Okay, but if you massage the last equation that we get and make it into standard form, you should get the same result. Okay, that's for number 2. The structure is not really nice. I don't really like that. You know what? Let me rearrange that. Let me rearrange that. Give me a second. So I will move this somewhere else. I will move this here. So that it looks better, right? I do left column and then right column. Okay, but I hope you prefer the method in Precalculus, the one above, a lot faster. Let's see part number 3. Number 3, you have this function fx equals something. Find the domain. The domain will be all real numbers except that 2x minus 5 cannot be 0. Right? So x cannot be 5 half. But you need to write that in interval notation. So domain is all real numbers except 5 half. Either you write it this way, which I say I accept that as interval notation, or the proper interval notation would be negative infinity to 5 over 2 union 5 over 2 to infinity. Basically, you avoid that 5 over 2. Number 3, solve that function for x. So we replace the fx by y, and then we'll solve for x. Basically, we need to have x itself on the other side, and no more x on this side. Okay, now the first step will be I multiply both sides by the LCD, distribute. I will subtract by 2x and then add 4y. So basically you will see we are actually switching this. This goes here, this goes here. Okay, and then we factor the x. X times y minus 2 equals to 4y plus 3. Therefore, the final step, x is equal to 4y plus 3 over y minus 2. Okay, now by the way, forward look, in future, we use this result to algebraically show that the range of the function is all real numbers except 2. So the y can be all real numbers except 2. Okay, that's for number 3. Now let's go on with the next page. This time I want you to solve this equation. So that's the equation. There are actually 5 questions on this page. Let me ask you to do these 3 problems first. Okay, A, B, and D. We do it in, let's say 3, 4, maybe 12 minutes from now. Okay, so we come back at 10, 12. Okay, try it. Again, I will leave my recording on so that students who watch this recording later on, they can measure the time. Okay, they can measure the time. Okay, you know what? If I do it now, let's say in 12 minutes will be approximately how long? Okay, but it's not that I suddenly disappear. Right now it's 10 o'clock precisely. So in 12 minutes, I will come back. Okay, let me start again. I hope you understand why I keep my recording on and why I want you to measure your time. Because of the following, when you study at home and I don't do it this way, I pause it, right? Then there is a chance that the time already passed 12 minutes, yet you don't realize that. Okay, that's one. Second, on the other hand, if I pause it and then when I start working on it, then I start the recording, you may feel intimidated that, oh, I need to do it that fast and get discouraged. So I try to place uh, your mind, your spirit to the proper place. Like, okay, how long should I take? How long should I do this problem to be appropriate? Okay, and not too fast, not too slow. Okay, not too slow such that you don't have enough time in the test, not too fast such that you get discouraged if you are not that fast. Okay, now let's start working on this. Part A, it's already something squared equals to a positive constant. So I will apply square root property. You know what? Let me rationalize that right away. So on the top and the bottom, I multiply by 2. Yeah, the purpose is so that the denominator becomes a square number 16. Okay, so this will be plus minus square root of 6 over square root of 16, which is 4. Now then, 3x equals to negative 1/2 plus minus square root of 6 over 4. And x is equal to this whole part here multiplied by the reciprocal of 3, which is 1/3. So x equals to negative 1 over 6 plus minus square root of 6 over 12. Okay. Oh, you can do LCD here. Let me multiply the first term by the top and the bottom by 2. So we get x is equal to negative 2 plus minus square root of 6 over 12. Now then I split it. X1 is negative 2 plus square root of 6 over 12. X2 equals to negative 2 minus square root of 6 over 12. Okay, that's for part A. Let's go on with part B. Part B, I use this idea. This is absolute of blah equals a positive constant, right? So either blah equals to 5 or blah equals to negative 5. Now then I will solve each branch and multiply by the LCD. That's standard procedure, right? 5 times x minus 2. Let me line it up here. So 3x minus 4 equals to 5x minus 10. I add 10 to both sides, I get 6, subtract 3x both sides, so x equals to 3. That's one solution. Now the other one, I multiply both sides by the LCD again. So 3x minus 4 equals to negative 5x plus 10. I add 5x to both sides. I add 4 to both sides. So I get 14 over 8 or 7 over 4. Okay, so this is x2, that's x1. That's for part B. Now part C, the challenging one. Part C, 3 times x to the 2/3. Oh, so you notice that this guy here, let me enlarge that further. This variable here has exponent which is twice the exponent of this variable. I mean, both of them base x. Notice that x to the 2/3 is equal to x to the 1/3 squared. Now, if you see this phenomena, and the other term is constant, if you see this phenomena, then we will approach this problem with quadratic-like equation. Okay, so let u equals to x to the 1/3. Okay, so u squared will be x to the 2/3. Now then, the equation becomes 3u squared minus 8u minus 3 equals 0. I believe this is factorable. So 3u minus 1, u minus, actually plus 1, u minus 3. So u equals to negative 1/3, u equals to 3. Now substitute that back, x to the 1/3 equals to negative 1/3. So when I cube both sides, when I take it to the power of 3, then x to the 1/3 being cubed is just x. So x1 is negative 1 over 27. Okay, on the other hand, x to the 1/3 equals to 3, so x equals to 3 cubed, that's 27. Okay, that's for part D. A, B, and D. Now for the next two questions, part E and part C. Let me ask you to do that in, let's say, in maybe 10 minutes. I think part E is a bit longer. Yeah, part E is a bit longer. Let's do it in 8 minutes. I don't think you will finish part E, but I do expect you to finish part C. Okay, let's do it in 8 minutes. So we come back at 10:27. Okay, do as much as you can in these 8 minutes. Basically, later on, you will have x minus 3 equals something, a positive number, x minus 3 in absolute equals to something, and then you need to break it up further. Okay, now from that part, I think it's just about time. But the early part, you need to think a little bit. Okay, now part C especially, that's one of my favorite questions. You have seen this question many, many times in my old test. Okay, this is the third test actually that you see this type of question for number part C. Okay, let me ask you to do that in 7 minutes from now. Okay, how is it? Morten? It's only you again here. Yeah, with our SI leader, of course, but
yeah.
I saw your work. Well, sorry. Let me unrecord this first. Okay, so let me do part C. This is absolute something equals to, we don't know if the other side is positive or negative, right? So let's assume that to be positive first, and we will do the checking later on. So I branch this out to be x minus 4 equals to 2x minus 3, or x minus 4 equals to the opposite of 2x minus 3. And then when I solve this, I get negative 1 equals to x, and then x minus 4 equals to negative 2x plus 3. So that will be 3x equals to 7, x equals to 7/3. However, I need to check each one of these solutions though. Okay, so I do the checking. X equals to negative 1 for x1. What will happen? Absolute of negative 1 minus 4. Is it equals to 2 times negative 1 minus 3? So this is absolute of negative 5. Is it equals to negative 5? No, because absolute of negative 5 will be positive. So it's not. With x2, so 7 over 3 minus 4, is it equals to 2 times 7 over 3 minus 3? This is absolute of 7/3 minus 12/3. Is it equal to 14 over 3 minus 9 over 3? This is absolute of negative 5/3. Is it equal to 5/3? Yes, they are equal. So the solution is x equals to 7/3. Okay, by the way, that's actually one method to do it. Let me show you the second method. Let me box it using different colors so that you can distinguish that. The one I did earlier was assuming that the other side is positive and then solve it, but then we need to check our assumption. Okay, that's the idea. The second method is we deal with the critical number right away. So we deal with this, we do it this way. If x minus 4 is non-negative, in other words, x is greater or equals to 4, then the absolute of x minus 4 becomes just x minus 4. Is it right? Okay, and then when we solve this, I get x equals to negative 1. But this is not greater, x is not greater equals to 4. So we crossed it out. Okay, now what happened if x minus 4 is negative instead? In other words, x is less than 4. Now then, the guy inside the absolute value is negative. To make it positive, I attach another negative. Okay, when I solve this, now you will see I don't need to check this anymore because the checking was actually done earlier. 7 equals to 3x. So x is equals to 7/3, which is less than x less than 4, right? Okay, the one here, that's not true. Okay, then we conclude, so x equals to 7/3. It seems like we don't do checking for the second part or for the second method, but that's because we did the checking already earlier. When x minus 4 is at least 0, what happened? When x minus 4 is less than 0, what happened? Okay, so instead of doing a long checking at the end, we do the checking at the beginning instead. Okay, now this second method is actually more useful, a better use, if you can see the critical number inside this absolute value a lot faster. It's like x minus 4, the critical number is 4, right? But if you have, let's say, absolute of 2x plus 7, then it's kind of a bit harder to see the critical number, right? Okay, it's negative 3 half though, but when we try to work it out, it may be a bit longer. So there's a trade-off between do you want to check it earlier, but harder critical number, or you just work it out first and then check it later, you know, okay? So either way is okay. Either the blue method or the green method, either way is okay. Yeah, I think the blue one is a bit longer. The work is a bit longer, but still makes sense, right? Still makes sense. Now let's see part E here. Just like before, notice that this term has the variable part as the square of the variable part of this term here. Okay, so we can say let u equals to absolute of x minus 3. Now then the equation becomes 2u squared minus 7u plus 6 equals 0, 2u, and then u, how to make it 7? Minus 2 minus 3. Will that do it? Yeah. Okay, so u equals to 3 halves, u equals to 2. So absolute of x minus 3 equals to 3 half. Absolute of x minus 3 equals to 2. Then from there we solve it again. Okay, but you will see we have actually 4 solutions, right? X minus 3 equals to 3 halves. X minus 3 equals to negative 3 halves. X minus 3 equals to 2. X minus 3 equals to negative 2. So this will be x equals to 3 plus 1.5, that's 4.5. Okay, that's 9 half. This is positive 3 halves. This is 5. This is 1. So this is our. So x equals to, maybe that's, I just underlined those right away. So this is my x1, my x2, my x3, my x4. There are 4 solutions for this. Okay. That's for part E. But I think part E is actually easier than part C. Part E is easier. That's basically the reinforcement on what we did in part D. Right? It's basically the same method, right? U substitution, and then solve for that. From that U, later on solve for x. Right? Number 5. Number 6 we cannot do yet. We will leave it until Wednesday. Number 5, solve this equation. Let me give you 4 minutes for this. We are done at, I will be back at 10:41. Yeah, try it. You factor this first and then multiply by the LCD. Okay, let me start working on it. I know you may not be done yet, but I believe you already see what we need to do. So the else, when I factor this will be x minus 5, x plus 3. So when I multiply by the LCD to get rid of the denominator, we get x minus 1 times x minus 5 equals to 11 plus 2 times x minus 5 x plus 3. And then I FOIL that. 11 plus 2 times x squared minus 2x minus 15 x squared minus 4x minus 30. Combine like terms on the right hand side. Set one side equals to 0, so x squared plus 2x minus 24. So I get x minus, that's 6 and 4, huh? Plus 6x minus 4. Okay, so x1 is negative 6, which is okay, right? And x2 is positive 4, also okay. So both of them are okay. When I say okay or not, it has something to do with the denominator. We check if there's any x, if the solution we get makes the denominator equals to 0. If it makes equals to 0, we need to cancel that solution. Okay, that's for 5a. Let's go on with 5b. Are you okay with this?
Yeah.
Okay, let's do 5b. I believe that's on the harder side. 5b, we have this radical here, and to solve it, let me give you 5 minutes for this. The thing is, because it's radical, that you may need to do checking later on. Okay, but our first step will be isolate one of the radical, and then you square both sides. You will still have radical after you simplify this. Okay, you simplify first, and then isolate the radical again, and then whatever your final answer, you check. Okay, let me ask you to do it in 3 minutes from now. I think this is doable in 3 minutes. Make it 4 because you need to check. Okay, let's start to work this out. So on the left hand side it's already x plus 5, the right hand side that's 1 plus 2 square root of x plus x. Then subtract by x, subtract by 1, I get 4 equals to 2 square root of x. Then I will divide by 2 and then square both sides. So I get x equals to 4 and then I check. Okay, now before I do the checking, let me say something. Okay, suppose, on the other hand, let's say suppose we get 7 equals to 4 square root of x. You can divide by 4 first and then square both sides if you like. And then you do the check. Or your other option is you square both sides right away. But when you square both sides right away, you will get 49 equals to 16 times x. Okay. Now, if instead you have square root of x plus 3, for example, then when you square both sides, it becomes 49 equals to 16 parentheses x plus 3. Okay. Now, the reason is because of the following. When you square both sides, it actually looks like 7 squared parentheses equals to parentheses 4 square root of x plus 3 squared. Right? Okay, so this will be 4 squared is 16, square root of something is that thing, but don't forget to use parentheses. Okay, now I tend to use the technique in green if 7 divided by 4 give me an ugly fraction, or basically if it gives me fraction. Okay, it's not that I'm afraid with fraction, it's just like I don't like, if I can choose to deal with nice people or not nice people, of course I choose to deal with nice people, right? Okay, in other words, if you think fraction are people or numbers harder to deal with, then this is one way to avoid dealing with that too early. Okay, yeah, but you should not be afraid with fractions though. No, should not be afraid with fractions. However, we know that, well, because that person is more difficult to deal with, so let's avoid that person as much as possible. Okay, now I will check this x equals to 4, square root of 4 plus 5 minus square root of 4. Is it equals to 1? Square root of 9 minus square root of 4. Is it equal to 1? 3 minus 2. Is it equal to 1? Don't forget to put the question mark above the equal sign. Okay, so 1 equals to 1. So we check. So x equals to 4. No, x is not equals to 1. X is not equals to 1. We are doing the checking and the other side is 1 to make it true. But the x that makes it true is x equals to 4. Okay. The next question, difference quotient, we cannot do this yet at this point, but I think we should be able to do it this Wednesday. We need to deal with functions first. This is the next discussion we will do though, the different quotient. But different quotient is one very, very important things we need to do in precalculus. And you will see that quite early in calculus class. I think the first 3 or 4 weeks, then you will see different quotients already. Okay, so if you watch the lecture on YouTube, my lecture on YouTube, you should have seen this in, I think you should have seen this in lecture number 7, lesson number 7, maybe even lesson number 6. I'm not sure, but this is supposed to be something you see at that point, and we will do this on Wednesday. Okay, likewise for number 7, we'll do this on Wednesday also, but this one is actually on the easy side. This one is on the easy side. You will see, if you watch my lesson, then you will see the following. Okay, fx is even if and only if, by definition, the graph has of fx has y-axis symmetry. Y-axis symmetry. Okay, now it will have odd the function is odd if it has origin symmetry. Now, because it has y-axis symmetry, then replacing x by negative x will give you the original function fx. So how do we check a function is even? Then you replace x by negative x and see if you get the original function back. On the other hand, if you want to check if it is origin symmetry, then replacing x by negative x will give us negative y. Okay, that's what we will do. But let's leave it until Wednesday. Okay, but if you watch the lecture video and the discussion I do tomorrow, you will see that's basically it. Okay, now once we know the function is even or odd or neither one, then we will be able to tell what kind of symmetry it has. Okay, so this question number 7 is actually on the easy side. Number 6 is not that easy. It's not hard either. It's just tedious. Yeah, and not that tedious though. You need to think a little bit more. Okay, but 7 tends to be on the easy side. Yeah, it's more about, do you know what it means to be even function? Do you know what is odd function? And how do you know it? Okay, now number 8, my favorite type of questions. Okay, number 8 and number 8A, B, and C. Oh, there are only 3 questions on this page. Can I ask you to do this? Okay, the part A, you will see kind of strange because it's not factorable. Okay, but every time, let me write this down. Let me write it down. Every time we solve polynomial and rational inequality, you need to show, especially in my class, you need to show explicitly, let me make it big, explicitly the 3-step procedure. Okay, make me happy, make me happy. I want to see that. I want to see you doing that. Okay, so for example, this one, step 1, what is 3-step procedure again, Thomas? Then you need to practice from my lecture and question and answer, right? But it's basically the first step, critical number. You set it equal to, actually on the top, I set one side equals 0 first. And then you solve that inequality as an equation to get a critical number, and then you do the sign graph. Okay, and then from there you do the solution. Now, you may not be able to factor it, but doesn't mean it's not solvable. You still can solve it in other method. In this case, I think completing the square will be good. Sign graph, and then the third step is the solution. Likewise for part B, but I think part B, it's still easy to find the critical numbers. And part C, of course, you need to factor it. Okay, let me give you 15 minutes plus. Let's come back at 11. Let's come back at 11:20 together with your break. So this should take around 10 minutes to do, maybe 15. Okay, plus 10 minutes break. Okay, so 11:20 we come back. I will pause this for 10 minutes and then we'll run it again for 15 minutes. Of course, there's no movement for that 15 minutes, just to make you aware with the time. Okay, but you need to show me these 3 steps for each one of them. Okay, talk to you later. Okay, let's start again. So I try to solve this. This is not factorable, so let me try another method. Because the leading coefficient is 1 and coefficient of x is even, I will do completing the square, and you will see we will add by 1 both sides. Okay, that's 2 divided by 2, always divided by 2, and whatever the quotient, you square it, right? That's how we know that we add 1 both sides. And the quotient that we had earlier will become something here. So the 1 here comes from this one. Then I apply square root property, x plus 1 equals to plus minus square root of 8, which is plus minus 2 square root of 2. So x equals to negative 1 plus n minus 2 square root of 2. Okay, and the critical numbers are negative 1 minus 2 square root of 2. That's clearly negative, right? And the other one, negative 1 plus 2 square root of 2. That's clearly positive. Okay, you can use your calculator to confirm. But knowing that one of them negative, the other one positive, I can choose x equals to 0 as my testing point. Okay, and I can test that right away to here or to here. Basically, you will see the y-intercept of that x function is negative 7. So this is negative. Okay, now those critical numbers are multiplicity of 1. How do you know multiplicity of 1, Thomas, without factoring it? Actually, I think a bit simple. The way I see is that this is a quadratic equation, right? Okay, now, and it has two zeros. Then each one of them must be multiplicity of 1. Does it make sense? Okay. Yeah, we will see I think we did that discriminant analysis already sometime in the past, right? Okay, and if you compute the discriminant of this expression here, this quadratic expression, you will see the discriminant is positive, and therefore it has two different solutions. Because this is polynomial degree of 2, then and you have two different solutions, then each one of them must be multiplicity of 1. Now, because it's multiplicity of 1, then when you jump across the critical number, you will change the sign. Okay, this becomes positive here, negative becomes positive, negative becomes positive. What you need is the positive one. So it will be negative infinity up to negative 1 minus 2 square root of 2 union negative 1 plus 2 square root of 2 to infinity. Okay, that's for part A. Let's go on with part B below that. You have less than equals to 4. Do not, maybe I write that warning explicitly again. Do not multiply by the LCD because we don't know if 2x plus 3 is positive or negative. Okay, that's not what you do. What do we do instead? We subtract both sides by 4 and then do the LCD. Basically, I simplify this rational expression into a simple rational expression with only one fraction. So I multiply by the LCD over LCD for the second term. get 5x plus 4 minus 8x minus 12 over 2x plus 3 less than equals to 0. So negative 3x minus 8 over 2x plus 3 less than equals to 0. Actually, if you want to factor the negative and then divide both sides by negative, that will do. Okay, let me do that. Let me do that. So I factor the negative and then divide both sides by negative. I will get 3x plus 8 over 2x plus 3 greater equals to 0 because I divide or multiply by negative 1. That's why I reverse the inequality sign. Okay. Now, what happened if I don't do that, Thomas? Will I get the same result? You will get the same result. Don't worry. Don't worry. You will get the same result. Okay, so let's start the procedure. Step 1. Step 1, what's the critical number? Regardless you divide by negative 1 or not, you should get the same critical numbers. Okay, so on the top, the critical number negative 8 over 3. At the bottom, the critical number is negative 3 halves. So for the sign graph, one of them less than negative 2, that's negative 8 over 3. Okay, and the other one is between negative 1 and negative 2, right? Negative 1.5. This will give us undefined, this will give us 0. Okay, so either you divide by this negative 1 or not, you will have exactly the same step 1 or step 2. Okay, now next. When I do the sign graph, I will work on this one, right? I will work on this one. I will work on that one. So I will use red color, okay? When I work on that one, when x is 0, when x equals to 0, I get that's positive, right? And this is negative, therefore this is positive. Because each zeros or each critical numbers has multiplicity of 1. So once I jump across that critical number, I will change the sign. Now then, step 3, we will look at the positive part, right? In the box here, the red box here, I do the positive part, right? Greater equals to 0. So it will be from negative infinity up to negative 8 over 3 bracket union parentheses negative 3 half to infinity. Okay, that's the solution. Now, suppose on the other hand, what you dealt with is this one. So you didn't factor the negative and cancel the negative. Suppose you do this one here. Okay, now then when you test x equals to 0, so I use green one right now. I hope you don't get confused. I play with the color. Okay, in your test, you do either the red one only or the green one only, totally fine. When x equals to 0 and you plug them into that green box, right, here to here, when x equals to 0, you see it's negative, right? Okay, that's negative, and therefore when you jump here, it becomes positive. When we jump here, it becomes negative. Okay, but then if you are going to the green route here, for your step 3, do you need positive or negative? For your step 3, you will need the negative one, right? You will need the negative. Now, the thing is, when you do the negative part, you will get actually the same answer, right? You will get the same answer. Negative or 0. So this may create some confusion to some people. So Thomas, should I divide by negative 1 or not? Well, it depends on, I mean, it's up to you. If you do so, then you deal with the red one. Just be consistent, okay? Just be consistent. What you don't want to happen is this. You factor the negative and then divide it by -1. So you're supposed to deal with the red one, but you go back and deal with the green ones. Now that will be bad, right? Okay. Now that's for part B. Let's go on to part C. Part C already 0 on one side. So I can just go ahead to get the critical numbers. That's 2x squared minus 3x minus 2 over x squared minus 4. Set it equals to 0. Oh, that's way too big. So 2x minus plus 1 x minus 2 over x plus 2 x minus 2 equals to 0. So the critical numbers are x equals to -1/2, x equals to 2. Notice that this happens twice, multiplicity of 2. It happens once on the top, and once at the bottom, right? So it has multiplicity of 2. And x equals to -2 happens once. So what about the sign graph? So -2 will give us undefined. -1/2 will give us 0. And then 2 will give us undefined. 0 on the top and 0 at the bottom. So it will give us undefined. Now then I do testing point, x equals to 0. When x equals to 0 and you plug that in here, you get -1/2 over -4, which is positive, right? Positive 1/2. So this is positive, right? Okay, now, but 2 is critical numbers with multiplicity of 2, which is even, so you don't change the sign. -1/2 is a critical number with odd multiplicity of 1. You change the sign, Now from for step 3, we need greater less than equals to 0. Less than equals to 0. So the negative or 0. So the solution will be from -2 to -1/2 inclusive. Okay, that's for this part C. It's very similar to part B, except that this time we have a critical number with even multiplicity. Now, let's go on to this second from the last question. It's supposed to be number 9 here. It's supposed to be number 9 here. Find the domain range, Y-intercept, X-intercept, and we will graph it. But this is mainly the material I will cover tomorrow, like transformation. Okay, but we can do some of them already. Like, for example, what is the domain? The domain must be the guy inside the radical has to be non-negative, right? Okay, now then we want that to be in interval notation. So it means 4 is greater equals to x. So the solution, the domain will be -infinity up to 4, including 4. The y-intercept, I need to compute f0, right? That's 3 minus 2 square root of 4 minus 0. That's 3 minus 2 times 2. That's 3 minus 4, which is -1. So the y-intercept is 0, -1. Remember, x-intercept, y-intercept are coordinates. They are not numbers. I want it this way. I want it this way. I want you to write it in coordinate. Okay. X-intercept, you set the y equals to 0 and solve for x. I move the radical to the other side to make it positive. If I divide by 2, I will get 3/2. Let me just square both sides. You can divide by 2 and then square, but what I prefer to do in this case, let me square first so that I don't deal with fraction too early. 4 times 4 minus x is equal to 9. So 16 minus 4x equals to 9. 7 equals to 4x. X is 7 over 4. Again, we are not done yet. The x-intercept is 7 over 4, comma 0. Okay, that's for the y and x-intercept. The range is something we will do on Wednesday, including actually we will go over all these problems again. Okay, on Wednesday, the problems that we have not done. So actually, if we look back, we almost finished spring 17 math 2 SMC test 1, but we didn't finish it. Okay, and then for 17 math 260 from West LA College, and then spring 19 math 260 test 1 and test 2. Part of that we cannot do yet, even though it's in our test 1, actually spring 19. And then from this fall 19 math 2 test 1, there will be some problem we cannot do yet at this point. Now on Wednesday, we'll finish the leftover. Okay, basically on this, by the end of this Wednesday, we are basically done with 4 of my old tests, 4 of my old test 1. Okay, and the blank files actually available on the discussion board. Okay, I give you the blank file. This fall 19 one, I make it available on the discussion board today. This is today's discussion board. And then the one here, the other 3 was on the previous discussion board. Okay, so see discussion board. This one here is from last Wednesday. So what's that? -5, the 3rd. And this is the one today. Okay, I think 4 all tests that I go over should be good enough, right? Okay, so I expect a lot of you can get at least 90 in your test 1. Okay, and show the work the way I show it here. Okay, because otherwise it gets more complicated though. Number 9 still require transformation to do, especially because we need to graph that, right? Let me mark it in this, which means we will finish it on Thursday, on Wednesday. This is number 10. This is number 10. Okay, but we can do some here, like the y-intercept. I think that's way too easy, right? The y-intercept, when x equals to 0, what is y? Oh, y equals to 4. Dang, you are done too. How about the x-intercept here? I always set the y equals to 0. Okay, and then we try to solve it from there. But I don't like that -1/2. Let me multiply by the reciprocal, -2, so that, use right color. So that I get 0 equals to x squared plus 4x minus 8. I don't think that's factorable. So let me do it by completing the square. Okay, so x squared plus 4x here. I add 4 to both sides. I hope you know where I get that 4. Right? That 4 divided by 2, this 4 here, this 4 here, divided by 2, always divided by 2. Whatever the quotient, you square it. Okay, whatever the quotient, you square it. That's how I get my 4 that I need to add both sides. So 12 equals to x plus 2 squared. So plus minus square root of 12 equals to x plus 2. So x is equal to negative 2 plus minus 2 square root of 3. Okay, but the x-intercept has to be in coordinate form. Negative 2 minus 2 radical 3 comma 0. Negative 2 plus 2 radical 3 comma 0. Okay, so on Wednesday we will continue working on this graphing. Okay, not too hard though, not too hard. With the time I have left, I can say a little bit. Okay, a little bit here. To find the axis of symmetry, remember axis of symmetry is always equation of a line that's equals to something. Okay, it's a vertical line, x equals to something. Now, how to find that C? There are two methods. The first method is that C can be seen as the midpoint of two x-intercepts. Okay, so that will be negative 2 plus 2 radical 3 plus negative 2 minus 2 radical 3. The midpoint of the x-intercepts. Okay, so 2 radical 3 cancels, I get negative 4 over 2, that's negative 2. So the axis of symmetry is x equals to negative 2. Okay, that's one way. That's one way. But the weakness of this method is what if you don't have x-intercepts? You can use another one, a formula, negative b over 2a. That's negative of negative 2 over 2 times a, negative 1/2. So I get 2 over negative 1, so x equals to negative 2. Okay, those are two methods that you can use to find axis of symmetry. There are actually other methods though. There are actually other methods. The one I like the most, of course, method number 2, because that's basically applying the formula. I should not use C here. Let me use K instead. Constant K. Okay. Now, once we get the axis of symmetry, then how to find the vertex? Notice that, let's say this is the parabola, right? And this is the axis of symmetry. Now, the vertex must be on the parabola and must be on axis of symmetry, right? Okay, the x must be on, the vertex must be on the axis of symmetry, so the x must be negative 2, right? But it also have to be on the parabola. Now, the fact that it is on the parabola, you plug that into the function. Okay, that's how we get the y. So this is negative 1/2 times 4 plus 4 plus 4. That's negative 2 plus 4 plus 4, that's 6. So the vertex is 2, negative 2, 6. Okay, well, anyway, I don't want to go too far into this. But that's basically one of the things we will cover tomorrow. After some transformation, then we'll apply that transformation into absolute value, into radical, into square functions. Okay, but that's what we will do tomorrow. And on Thursday, we come back and attack all the remaining questions from this test that we have done so far. Okay, I'll see you then on Wednesday.